So given the fact that a charge Q is equal to negative 3.8 times 10 to the minus 6 coulombs. Oh, I forgot my negative sign there. So minus 3.8 times 10 to the minus 6 coulombs. And point A has a distance r sub A of 0.62 meters, and point B has a distance r sub B of 0.88 meters. So using that, we can determine VB minus VA. So VB minus VA. Okay. Well, we can do that using equation 17-5, which says that the potential is equal to the constant K, which is 1 over 4 pi epsilon naught. It's equal to 8.99 times 10 to the 9 newtons times meters squared per coulomb squared. So it's KQ divided by the distance, R, in this case, R sub B. But the potential V sub A is also going to have the same K and Q value. So we're just going to pull that out front. So this is equal to KQ times the difference between 1 over R sub B minus 1 over R sub A. So plugging those values into this expression, we find that this is equal to 1.6 times 10 to the 4, and then the units here are the units of potential, which is volts. We can box that in as the solution to the question for part A. We'll start a new page here. For part B, we are asked to find the magnitude and the direction of the vector, the electric field E sub B minus E sub A. Okay, well, let's go ahead and draw a little diagram to represent this. E sub A, we're told, is going in this direction with the magnitude, of course, of E sub A. And then E sub B is a vector in this direction. Therefore, this vector here at some angle, theta, which we're asked to find, is E sub B minus E sub A. Okay, so then the magnitude, using Pythagorean theorem, of E sub B minus E sub A is going to be equal to the square root of E sub B squared plus E sub A squared, because those are the two sides that make it up. Okay, well, what's the equation for an electric field? The equation for electric field is K, which is 1 over 4 pi epsilon naught, times the charge Q, which we were given, divided by the distance squared. So this would be R sub B squared. Okay, and then this is all squared because it's E sub B squared. And of course, this is all under the square root. And then we just do the same thing for E sub A. So this is going to be K times Q divided by R sub A squared. And this is all squared. So plugging those values into this expression, we find that this is equal to 9.9 times 10. Sorry, I couldn't read my handwriting. Times 10 to the 4. And since the electric field, it's volts per meter. We can box that in as the first part to our solution for part B. We're also asked to find direction. Well, using our trigonometric identity, the tangent of theta is equal to the opposite over the adjacent. So it's equal to E sub A over E sub B. So therefore, theta is equal to the inverse tangent of E sub A divided by E sub B. Well, so this is tangent to the minus 1. Well, E sub A over E sub B, the K and the Q are going to cancel. So you're going to be left with this is equal to the inverse tangent of R sub A, or excuse me, R sub B squared divided by R sub A squared. Plugging those values into this expression, we find that this is equal to 64 degrees. We can box that in as our solution to the direction.